started soon. Yep, we have the recorded started. So I know some people will join later and we'll make sure everyone's caught up to speed. But welcome back to class number 6 of Python level 1. And let me admit Mason. Let me start with my screen share, like always. So last week we covered arrays.
Hello.
That was hello, Mason. The last thing we covered last week was talking about our new data type arrays, where an array was basically just a collection of a bunch of variables. So you can make, or I guess I called them lists last week. So a list in Python has square brackets, and then you put items inside of the square brackets and you separate them by commas. You can append to lists. And then we also saw that they function a lot like strings, where you can access a list at a particular index. You can get a slice of a list using like a start index, :end index. You can find the length of lists, just like how you find the lengths of strings, so on and so on. So for review this week, it'll be a little bit different because I didn't get as many attempts at the homework as I would have liked. I want to take just a quick moment to go over the homework solution in class. So here I kind of started a write-up of not the solution, but a skeleton, and we just have to fill out some blanks. So the problem that I gave you guys last week was I have initially 2 strings. You can see them here, and these I just gave them to you. So the first step of the homework was turning these strings into arrays, or lists. Does anyone remember what kind of function we use to turn strings into lists, and maybe how it works as well?
Whatever dot split and then quotes and then whatever you want to split.
Exactly. And can you go into a little bit more detail what splitting means? So if we split on a space, what does that mean?
It means eliminating all the spaces kind of and like splitting the words and adding commas there.
Yeah. So what you said is exactly right. Whatever you're splitting on, you kind of search your string for that thing, that pattern. Whenever you find it, you kind of delete it. And then that leaves you with 2 different strings, right? Because you just cut out a chunk and now you have 2 pieces. And you keep doing this, you keep removing the pattern wherever you find it. And now you have a bunch of separate strings. You turned one big string into a lot of smaller ones. And then what you do, I want to be a little bit careful here. We do add commas, but that's not like a string comma. We don't do anything, we don't add anything to the string. Instead, the commas are because we're putting them into a list. And so since they're in a list, they're now separated by commas. But that's very right. So for the first string, we want to split every word from each other. And so we want to split by spaces. There's 2 ways you can do that. You can do x.split space inside the parentheses, because literally we want to split on spaces. Another way to do this is by default, split actually uses spaces as the separator. And so you actually don't even have to specify anything in this specific case, just because by default split splits by spaces. And for the second one, does anyone want to tell me, maybe someone new, what I should split on this time? Hint, I only want the numbers in my new list. So I want to get rid of the comma as well. So, and then I need something inside the parentheses. What should I split on for the second string? How about Mason? Do you have an idea of what we should split on for the second case? The hint we want the list to become 100, 234, 652, and 3. That's what we want our list to contain. So what are we cutting out? What are we chopping away? Oh, let's see, is it in chat? Okay, so Amy says the commas and the quotation marks. That's close, very close. I agree that we need to split on the comma because we want to get rid of the comma, right? We want to get rid of the comma in the string. I know why you said quotation marks, and the quotation marks is a good idea, but remember these quotation marks are only there because it's a string. We're creating a string, and whenever we create a string, we always have the quotation marks, but it's not actually part of the string itself. And so the correct answer is a comma and a space, because you can't just do the comma, or else now you're gonna have like random spaces in the string. You want to make sure you specify everything that you want to split on. So here we want to split on the comma and the space. Like it's not two separate things, it's one bigger pattern to look for. So now instead of looking for a space, we're looking for a comma followed by a space. And whenever we find that, we kind of cut it out and then separate the pieces from each other. And so hopefully you can see, let me just print out the results. So if I print out X array and Y, right, you can see that the first one has every word as an element in the list, and the second one has every number as an element in the list. Note really quickly that the list still contains strings. So these technically aren't numbers, these are still strings. We will actually look later today how to convert strings to integers. But for now, that's all. I didn't need that, I didn't require that. So this is kind of the first step of the homework, converting these strings into arrays and knowing what kind of pattern do you need to split on. The first one, you can use the default space. The second one required a little bit more effort. So the next part of the homework was getting the lengths of the two arrays, the two lists, and then comparing them. And so the first step is just getting the lengths. So does anyone remember how to get the length of a list? And a hint, it is exactly the same as how you get the length of a string. Yeah, so as in chat, thank you, Derek. It's a len function, L-E-N. So how the len function works is a little bit different than like the split. Instead of having a string dot split or an array dot split, you do len, and then you pass in the thing that you want to find the length of as a input, right? So it goes inside the parentheses. So you're doing the len of x ARR and the len of y ARR. And so this just takes the array, takes the list, and figures out how many elements are in there. That's what the length is for a list. How many elements are there? How many spots do I have? And so if we take a look, the length should be 1, 2, 3, 4, 5. No, I'm counting by 1 here because we don't care about indices. We're just talking about how many elements are there. So in this case, I do count by 1, starting at 1. 1, 2, 3, 4, 5. So x len should be 5, and then y len should be 1, 2, 3, 4. And so now the rest of the code here, I've already filled it out, but I do want to ask a question here. Just a quick review. I do this expression, x len greater than y len. Can anyone tell me what the type of this result is? So I do this computation, I compare the results. What is the word that we had for the type? So like I'm looking for something like int, string. It's not going to be one of those, but I'm looking for a type of variable or a type of expression. As a hint, it does start with the letter B. Yeah, Thank you. Boolean. So yeah, thank you, Amy, as well. It's a Boolean. So a Boolean's, we talked about it quickly. We're gonna actually see more examples of Booleans this week as well. Booleans are just true false values. So when you do this comparison, xlen greater than ylen, if we didn't actually know what xlen and ylen are ahead of time, sometimes you don't know what the variables contain. There's no way of knowing. In this case, we do, but imagine you didn't know what they were. So you don't know what if this is actually true or false, but you know it's one of the two, right? You know it's a Boolean. And so we store that into a variable and we just print it out. So if I run this, you might have guessed this prints out true because indeed xlen is greater than ylen. So again, this is not saying xlen must be greater than ylen. This is not like a math greater than sign. This is more like, is it greater than? We don't know. It might not be, but we're making a guess. Is it greater than? True or false? This is different than like the math greater than, where like you can only use greater than in math if it's actually greater than, right? In programming, it's a little bit more flexible. We're not saying it is, we're just asking if it is. So there's a important difference there. And finally, we had the last part, which is sorting an array, which sorting is a very useful function. So I'll begin by doing xrr.sort. And if I print out what is, we can see this. So originally, the list contained the words just in the order that they appeared in the string. After I do this sort function, you'll notice that the order of the words are now all over the place. Right? Now it says the daily developer good practices. That's not how they were in the sentence originally. So here we already see an important thing. The sort function modifies the list. It actually moves the items around. It doesn't give you a new list. It just modifies the old one. So sometimes you want this, sometimes you don't, and you have to be careful. But we talked about two optional parameters that you can add to the input of this sort function. Two parameters that allow you to do a little bit more control of how the sorting happens. So does anyone remember one of the parameters or one of the things that we can tell the sort function? Okay, yeah, so Derek gave maybe the harder one, but we can tell sort this key expression. So if we say key equals len, or typically there's no spaces, but spaces don't matter. If you say key equals len, what this is saying is the key is how the elements are compared to each other. Like in what way do you compare the elements to each other by? And so when we say key equals len, we're saying compare them by the lengths, right? So we have to give it a function. So len is a function. Notice we don't have parentheses because we're not calling the function. We're not using the function here. We're saying, hey, you will use the len function, right? I'm not using it right now. I don't need to call it. I don't need parentheses here. I don't need len with parentheses after because I'm not using the len function now. I'm saying the sort function will use the len function. So it's kind of like nested. So I just give it a name of a function. By default, it's like alphabetical order. When we say key equals len, if I sort it and print it out, you can see now, oops, had an extra parentheses. Now, if you look, the ordering is still not the original one, but it is different. It's the good daily developer practices. Notice now it's in ascending length order. The shortest word is at the beginning, the longest word is at the end. And so now, for example, I want to reverse this order. I want to do longest first and then shortest last. And that's the other thing that you can tell the sort function. You can tell it reversed equals true or false. By default, it's false. It's not reversed. if it's not reversed, it's going to be ascending order. If you say reversed equals true, that will just flip it around and just do descending order. So here now you can see it's pretty much the same ordering, except I've just turned it 180. The longest word is at the beginning, the shortest word is at the end. Right. And you can use one without the other. You can use both, you can use none. It's very flexible in that way. So that's all the review for lists in Python that I really wanted to go over. This homework, I think, covered pretty much everything I wanted you guys to remember about lists, at least the important topics. So if you didn't have a chance to do the homework last week, take a look at this. I will be posting this to Classroom, but take a look, make sure you understand what's happening at each line. If it helps, you can just print out what the different variables are at any given time. I think that helps me when I'm learning or looking at code that I didn't write. Sometimes I'm not sure, like, oh, okay, I say this variable equals this complicated expression. What does that even look like? I don't know. So then I print it out, I try to experiment with it. But this was the homework answer. Before I go on to new information, and you guys have any questions about lists or anything we've covered so far, really? Booleans lists are really the new things. So I see some shakes. So I guess the only thing that the homework didn't do a lot on was the indexing part, the slicing part. I think hopefully you feel kind of comfortable with that from working with strings. But for example, let me just add some more code. For example, if I wanted to slice this part of this list out, right? So XARR contains these 5 words. I only want the middle 3. How would I do that? Well, I can say middle, just any variable, is equal to the original list. And I want to start my slice at index 1. And remember, the slice includes the first index. And I have a colon, and my stopping index is not the index of good, but the index of the, because slices go up to, but not including whatever you put as a stop index. So the index of the is 0, 1, 2, 3, 4. So I want XARR 1:4. And if I print out what middle is, you can see it is exactly the middle 3 words in my list. I can also just access like a single word. So if I say word equals XARR, and I want the word at index 2, for example. Just word, you can see I get daily because that's 0, 1, 2, index 2 right there. So again, hopefully that should look very similar to what we've done in strings. So it shouldn't be too surprising, I hope. If I don't see any other questions, I can move on with the new material. I think we're gonna cover not too much, but I think we're gonna start getting into some more interesting things in Python, because we've really reached the point where you know a lot of the basics already. And so we know enough now that we can create some like actually interesting programs, I guess. Up to this point, we've only really known how to do like we only started with numbers, and then we went to strings, words. Then we went to lists. Really learn these data types. Now we have all these under our belt. We can use them to solve different problems. And we'll see that towards the end of today's class. But with the slides, the first thing I want to cover today is kind of short, but pretty interesting and pretty powerful. It's how to get user input. And so when I say user input, that means whoever is the human, whoever is running the program can enter some sort of text and enter some sort of input, and then the computer will take that and do something in the program with it. Right? How do you give the program something from yourself, the human? So how does the human talk to the program? And so in Python, it's actually super easy how to get user input. There's a very convenient function called the input function. And so here we see an example, the most basic example of the input function. And if I just bring this into my Colab, x equals input, print x. And when I run this, we're going to see something that we've never seen before. All right. If I run this, you can see all of a sudden, it doesn't stop. It's still running. It's waiting for me. It has this text box, and I see my cursor blinking. It's waiting for me to type something. Note that this is how it looks like on Colab. So if you run this in somewhere else, like an IDE like PyCharm or something like that, it's going to look a bit different. I think PyCharm I've used a lot. It will have an area at the bottom of the screen where you can type any inputs that you want. I can show that really quickly. So if I can also run it in my command line, and so if I do like x equals input, you can see now there's no box for me to type, but I can type whatever I want. So like hello, and then I do print x, and it prints out hello because it recorded what I typed in. And so if I close this, drag the windows around, close it. I can finish this. Hello world, right? That's my input. I hit enter, and this is because of what I typed, and this is what the program prints out. But I could easily change this. Instead of printing out X, I can print out the first letter of X, right? So if I type in hello world again, instead of printing out hello world, it just prints out H, right? Notice really it's just once you call this input function and store it into a variable, you can do whatever you want with it, right? It just becomes any other variable. But based on what we've seen here, does anyone want to make a guess of what the type of X is in this code example? Kind of gave it there if you saw it, but I want to know what type this is. Is it a number? Is it a string? Is it a list? Is it a Boolean? Is it something else? What is the type of this variable here? AKA, when I do input, the computer receives my message. And then how does it store it? What does it store it as? How about Evan, do you want to make a guess? What do you think the type of variable X is in this example? So I run the input function. I get some sort of result. I need to store it into a variable. What is the type of it? What kind of variable is it?
String.
Yeah, that's exactly right. It is a string. And actually, no matter what you type in, it will always be a string. And I think it should make sense if you think about it, how it would be implemented, because you really have no control over what the user puts in, right? You can tell the user to type in a number, but they could easily just type in the letter A, right? It's not very easy to restrict what the user types. So to make it simple for us, we just take in the input as a string, no matter what it is. Because definitely it can be represented as a string because it's something someone typed. It's definitely a word or a text of some sort. So we can turn it into a string and store it that way. If it so happens to be something else, we need ways of converting it into whatever we want it to be. Before that, that's a sneak peek of the next thing. If you want a little bit more of like a nicer function, right now you can see it just gives me a blank box. It doesn't tell me any sort of instructions. So the input function, actually, you can pass it some sort of input or a parameter to the function. And the parameter to the function is just some sort of prompt that's given to the user. So instead of just giving an empty box, it'll say some sort of message first and then give the box where the user can type whatever they want. So here we can say like input, what is your name? Right. And when I run this, you'll notice instead of just giving you a box, it also has a message. You can think of this as it's almost like doing a print statement in Python and then doing the input statement. It's not necessary for anything, but if you're writing a program for another person, it's definitely really helpful to give them instructions on what they should type in, what you're expecting. So I can type in my name, and you can see it says J because this is still what it is. But if I change the print statement to like hello plus X, and then I'm also going to add a exclamation mark because I want it to be happy. So if I type in my name now, it'll say hello Jack. I can type in anyone's name. I can say Bob. I'll say hello Bob, right? So here we see really our first example of a program that does different things every time you run it, right? Before, all our programs, you run it, it does something, you run it again, it does the exact same thing. This time, it's a little bit different, right? The code is still the same, but depending on what I type into this box, my program will do different things. So that's, I think, pretty interesting because programs that do the same thing, yeah, they're useful, but they're not really interesting. It's kind of like a calculator, right? Like, you know what a calculator is going to do. If you type in 2 + 2, it's always going to do the same thing. But I think it's more interesting if programs do different things depending on what you give it. Let me just finish this, Mary. So now about the whole type conversion thing. First of all, why do we want to convert these types around? Well, let's think of a very simple example of like a calculator app. So if I said first equals input, enter a number, and then I get a second input that says enter a second number. And then I want to say the result is equal to the first plus the second. So it's almost like just doing a simple addition operation and then print out the result. If I run this program and say like, I want to add 5 and 8. So really quickly, before I hit enter and make it finish, what do you think the result will be? What do you think will be printed after I hit enter? I think there are, yeah, okay. So Derek said 58 or 13. I'd agree those, it will be one of the two. So Amy says 13. Anyone else want to give an answer? I just want to give some time before I actually reveal it by hitting enter. So I'd say as a hint, Evan very helpfully told us that the result of calling the input function is a string variable. So first and second, these are strings. So what happens when we add strings together? What does that do? I'll reveal the answer now. When we add strings together, unfortunately, we don't do math we just concatenate the strings together. We put one string after another. And so this is going to result in 58. Because while it looks at first like it's what we want, like some sort of calculator addition app, instead, since we never convert the strings into ints, all we're doing is adding strings together, right? Again, this goes to the point where I say enter a number, but I could easily have said like Jack and Leo. And then the result is my name, except for a space missing, right? There really is nothing stopping me. There's nothing telling Python, hey, these are numbers, right? Python just says, oh, they're strings. I'm just going to do string addition instead of integer addition. So the way to convert strings into integers, or really anything into integers, is with the int function. So, so I can say first number equals int first. So what this does, let me just write the second line, is like this. So first is the result of our input function. It's what we got from the user, could be anything. And when we do int first, it's basically saying, take that string, turn it into an integer, right? I think it should be pretty clear what happens if it works. Like if first is 8, obviously it's just going to become the integer 8. If the string was 883, then that's going to become the integer 883, right? That should make sense. I think what might be a little bit more interesting is what happens when we don't give it something that's clearly a number. What if we give it something that's a bit trickier to convert? Will it still succeed? But let me first change my code. So now if I run it and I do 5 and 8 again, oops, I typed a little bit too fast. 5, 8, you can see now it prints out the quote unquote correct answer of 13. Now it actually does arithmetic because I've converted my inputs to to integers. Sorry. If I try it now and say 3 and 5, does anyone want to make a guess? Do you think this is going to work? Do you think this is not going to work? Is a hint, like, well, not a hint, but I definitely did not tell you the answer ahead of time. This is purely, I'm just interested in what your guesses are. So Derek says no. Does anyone want to guess differently, or do they agree with Derek? Do you think this is not going to work? Really, do you think Python can convert like 3, this like THREE to the number 3? Or is it not that sophisticated? So if I do run it, we will see that it is correct. This is not gonna work really. It can't convert THREE into the number 3. It's not that smart. It has to be exactly like a digit, like first has to consist of only digits 0 to 9. It can't have any letters in it. It can have decimals, I guess, although decimals can't really be converted to ints. So you have to be careful with that as well. So we saw this is like, could be a bug if you don't convert it to integers. However, it can also cause errors. So in Python, you can't add integers and strings together. Right? If you try to add an integer and a string together, it's going to say unsupported operand types for plus int and string. Right? Even if I do like 8 plus the number 8 plus the string 8, it's going to complain. Right? You have to always explicitly, you have to convert yourself. You can't just let Python convert for you. So here, to make it work, you can say int 8, and this will give you 16. Or on the other hand, you can convert the number into a string. And the way you do that is with the str function. So the int function turns things into integers. The str function turns things into strings, right? And if I run this, anyone want to put into chat what this should be? str8 plus the string 8. Yeah, 88. Or not really 88, but the string 88. Right? It's not a number, it's a string. So perfect. Let me get rid of this error message real quickly. Yeah, so that's really all there is to user input at this point. Any questions on it? I think it should be relatively clear because there really is only one function that does it. There's not too much involved. You can give it a prompt, you don't have to. You can convert the result if you need to. That's really all you need to know about user input at this point. So go back here. The slides are pretty much what I've already covered. One note is that this thing that I've been talking about, like converting one type to another, the technical term for this in programming is called typecasting. And so typecasting exists in all sorts of different languages. It's not a Python thing. Typecasting exists in pretty much any language with types. But yeah, that's just what it's called when you convert like a string to an int or an int to a string, or really any type to another type. It's called typecasting. So really that's what all the slides were about for user input. I covered everything in examples. If you want to look at the slides later, they will be posted as well. But the second half of today's class, and also I think something that should be interesting, that allows us to have a program that does different things according to different rules, is this idea of conditional statements. We already saw conditionals before, like x greater than 6 is a comparison. A conditional statement takes some sort of expression, a Boolean expression specifically, and it basically says like this: if this is true, I'm going to do that. This ELIF thing stands for else if. So else, if this other thing is true, then I'm going to do this one instead. And then finally, else, if none of the previous ones were true, I'm going to do this third one, right? So this is an example of an conditional statement or a conditional block. One thing that we have not seen before is the use of tabs. So tabs are a way of Python to denote blocks of code, sections of code that belong together. And so we need that here because when we do the if statement, so this is called the if statement because it has an if, we need to know what lines of code after it belong to the if statement and what lines of code belong to other things. And so to show what lines of code belong to the if statement, they're all followed by a tab. So here the print has a tab in front of it. It means it's indented in. That means it's part of the if statement. If I didn't have the tab, then actually this would be an error, like it wouldn't compile. But it would essentially mean that there's nothing in this if statement, is just something else. It doesn't belong to anything. Just put it back where it belongs. There. Similar here, we have the else if, we have the indented block to show that it's part of the code block. And the other thing with the code block is that there's a colon. So whenever you see a colon, that's the start of a code block. Everything after the colon should have an extra indent. Right? And then whenever you're done, ready to close the block, you just stop indenting. You just go back to where you were before. And that way Python knows, hey, these 5 lines belong to the else statement. The other lines of code are separate. Right? So that was really brief. Let's go over some examples. I'm not gonna mess with the user input, although you could. I'm just going to create a variable x equals 5. Right? And so now we can write our conditional statements. We'd say if, let's do something simple actually. So if x equals 0, I'm going to say print I. Okay. If x equals 1, I'm going to print by. If x equals 2, I'm going to print bula. And if x equals 3, I'm going to print Chinese. And I could go on forever. If x equals 4, print, I don't know. I'm just going to print stars. Right. And so here, if I run this, you can see it prints out the third one. I can change what x is. I can change x to 0. And now it prints out hi. I can change x to 4, and it prints out the stars. If I change x to 99, it prints out nothing, right? And so if we look at this, this is a very simple example of conditionals, but it's actually an example of 5 separate conditional statements. So these are separate things from each other. They check different things. So here it's possible, and here it's not possible. But if you had an example where 2 of these statements could be true at the same time, then it'd run both of them. Because every time you write if, every time you have an if statement, you start a conditional block or a conditional statement. And this conditional statement can have an if statement, it can have else if statements, and it can have an else statement. If you don't have any of those, then you just end the conditional statement altogether and you can start a new one. So it's a little bit confusing, I know, but here this is one conditional statement. Here is a separate one, right? And so these are independent of each other. They don't care what the previous one did or didn't do. However, you can make it dependent. So here I can say if x equals 0, print hi. I can say elif, which means else if x is greater than 5, print by. And I can say else print error. It didn't know what to do, right? Actually, let me say else if x is less than 5. Right. And so if we look at this, what happens now is because these are now like, this is all one chunk of code that belongs together. The if, else, if, else structure, they're kind of just one conditional with 3 different choices. You can think of it like that. And so one trick with conditionals is that only one will be executed, right? You guarantee that only one of these, hi, by, or error, will be run, not more than one. You can't have both. So notice these conditions do overlap with each other, right? If x equals 0, do this. If x is less than 5, do that. 0 is both equal to 0 and less than 5. So if x is equal to 0, it satisfies both of these conditions. However, it will just do whatever it finds the first. So here, because our first condition is x equals 0, it will do this one. And it will, once it does that, it ignores the rest of whatever follows here, right? But once one of these clauses is satisfied, it will do whatever is inside and then skip everything else and go to the end and move on to whatever is after. It doesn't keep checking. And so, for example, if I do x equals 0, it only prints hi. Even though x is indeed less than 5, 0 is indeed less than 5, it doesn't print out by. And that's just because only one of these can be run. And so because the first one is run, once it does that, it doesn't even try to check the other ones. And so here, if instead x equals 1, then we go through this. Is x 0? It's not. So we don't do this. Well, is x less than 5? It is. So we're going to do this statement. We're going to print by. And since we do this, we don't care about the else. We don't look at it at all. And so this one is going to print out by. It's going to be the same for 2, 3, and 4. But once I get to 5, let's step through this again. Is x equal to 0? No, it's not. Is x less than 5? No, it's not. And so this last one is a little bit special because there is no condition. The else clause is kind of like the bucket case where if none of the previous things worked, I'm just going to handle it here, right? I don't have a condition. If you reach this point and you didn't fall in the previous categories, I'm just going to accept it. Right? And so basically at this point, it doesn't matter what x is. If you got to this point, it's going to print out error. Right? So if I have x equals 5, it is going to print out error. Really anything greater than 5 is going to print out error. But something like -6 will work in this example. What will x equals -6 print out? Can anyone tell me? So look through these statements. Dex is by. Yeah. Yeah, exactly. The way we answer this question is we look at the statements one after another. Is x 0? No, it's not. Is x less than 5? It is. So we go into here, we print by. And since we satisfied this, since we ran this, we don't care about the else. We already did one of them. We don't have to bother with the rest. A note here is that the else if statements, you can have as many of them as you want. You can have an infinite, quote, in quotes, infinite amount of them. It's really, you can have 0, you can have 1, you can have 5, you can have 10, you can have 100, you can have as many as you want to write. It's technically not infinite because you can't have an infinite program, but you can have as many as you want. So I can say L if x is greater than 10, print big number. So here, this still does the same thing because it's still -6 is still less than 5. So we do this one, we don't ignore everything else after. But now if I type in like x equals 100, now this won't say error. Now we'll do this else if, right? Because I added another clause. I added another else if clause. And so because of that, it has one more thing to check. Now it will only give me error if I give something between 5 and 10. Right? So if I say 7, notice 7 is not 0. 7 is not less than 5. 7 is also not greater than 10. So we just fall into the last case, the else. Right? Also, I saw this before, you don't need the else case. It's perfectly fine to have only ifs and else ifs, or even just ifs by itself. The else is optional, the else ifs are optional. You can have 0. The only difference between else if and else is that you can only have one else if you have it. You can't have more than one. The way to make sense of that is that the else is meant to be, if it doesn't fall into the previous categories, I'm going to accept anything here. So it doesn't make sense to have multiple else's because you're always going to fall into the first else if you get there, right? The else has no condition. You don't need to satisfy anything to go into the else clause. And so everything, if it reaches it, is going to go into the first else statement. There really shouldn't be anything after that, right? It doesn't make sense to have multiple else statements. Last thing is the order kind of matters. For the words, you do need to start with an if. Anything after should be an else if, and then the else has to go at the end. Right? And the order in which these are checked is top down in the order that you wrote them. So the first thing that's checked is the if. The next thing that's checked is this one. The third thing that's checked is this one. And the last thing it's not really checked, but then it does else. right? So if you swap these things around, it can cause problems sometimes. So for example, if I swapped this one around like this, so I swapped the conditions around, right? And now instead of checking if x equals 0 at the first beginning, I now check it in the middle. Can anyone see a problem with this already? Just curious. I claim that this will not behave the same way as before. Derek, I see you nodding. Do you want to explain why this is different and why it might be like a bug?
Because if x is 0, then it will check that if x is less than 5 first, so it will print by instead of high.
Yeah, so that's a great way of explaining it. Really, the problem with this is it's actually impossible for this to be checked, for this print high to be run, right? Because if x equals 0, right, if it wanted to go into here, well, the first thing that we check is if x is less than 5, like Derek said. So if x equals 0, it's definitely less than 5. And so it will always be true for this first one. And since it's true here, we print by. And like I said, we only run one of these statements, right? We have all this code, but only one of them is run. And so since it runs this one, it doesn't bother checking the rest of them. So sometimes when you have these overlapping cases, it's really important the order that they show up in. Just checking time. I think in the last 8-ish minutes I want to talk about one resource that I'm going to use for the homework. We're going to do a little bit more condition stuff later. But there's a site called CodingBat. You might have seen it, you might not have. If it's your first time learning a programming language, you probably haven't seen it before. But I'm going to put it into the chat. And it has a lot of different exercises just to practice Python. It also has Java practice if you're interested, but this is a Python class, so we're focusing on Python. But for example, I can go to string 1, and these are different string questions. So let's look at the first problem here. I'm gonna zoom in a little bit. So here it says, given a string name, return a greeting of the form hello name. Right? So if the name is Bob, I want the string hello Bob. And so I actually kind of did this in class. So I'm gonna redo this. The thing that we really haven't seen yet is what's going on here, the code. Let me make the font size a little bit bigger as well. We're writing a function. And so here, the instruction says we're given a string name. That means we're given a variable that's a string, and it holds the name of some person. And so if we look at the code that they already gave me, that's really what it's telling us here. If you look in the parentheses, these are our inputs. So we're given an input name. We're given this variable name, and it will hold, it can hold anything. It can hold any string, right? And we will take this input and we will return the thing that we want, which is the word hello plus the name plus the exclamation mark, right? So the answer that we want is hello, or hello with a capital H, with a space, followed by the name, followed by the exclamation mark, right? And now the new thing as well is we want to return this answer. But what this last line of code is saying is that, well, we've found what the answer should be. Now we just need to basically pass it to whoever's checking us. We need to return the result. Because it's fine that we have it, but we need to pass it to someone else. So we say return a variable or an expression or some sort of value. And so here the value is hello plus the name plus the exclamation mark. And so if I hit go, you can see it has a bunch of test cases. So it says, hello name Bob should give us hello Bob. Hello name X should give us hello X, so on, so on, so on. And you can see this is, the second column is kind of the result of our function. And the last column is whether or not it matches the expected result or not. And so we can purposely make a bug. What if we accidentally had 2 exclamation marks? You can see now all the tests fail. You can see it expected hello Bob, but it got hello Bob with 2 exclamation marks. And the part that's wrong is highlighted in red. And so I'm just going to do a couple more questions the time we have left. Let's look at this one. Okay, so here we're given 2 strings A and B, and we want to return the result of putting them in the order A, B, B, A. So for example, if A is the string hi and B is the string bye, we want to return the string hi, bye, bye, hi. So I guess, does anyone want to take a stab at this, try to solve this? I think the general pattern, you can have some code here if you want to do some sort of computation. And then I would say, put your answer into a variable. You can call it whatever I want. I'm just call it answer. The answer should be the result that we want to return, and then you just return the answer. So really, there's not much computation that we need to do. How can we get the answer that we want? The string in the order A, B, B, A. Anyone want to give me what should go in this blank? So a hint, it's going to be a bunch of concatenations. So Derek, I see you have your hand raised.
You could, so I think what you have to do is print the string hi bye and then reverse it.
So that's one approach to it. I'd say it's close, but it's a little bit off, because if you reverse the string, it's going to reverse the letters as well. So if you like reverse hi bye, that's going to be like E, Y, B, I, H, right? If you flip it that way. Yeah. And so I think the answer is actually a little bit
Like make it into a list and then reverse it.
That'd be one way of doing it. And I think that would work. However, I think the answer for this one is a little bit easier. You can just return the strings concatenated together. So we want the string, the A string, then the B string, then the B string, then the A string. So we can just literally do that. We can do A plus B plus B plus A. Right? So if A was the string hi, B is the string bye, it'd be hi plus bye plus bye plus hi. Okay. And if we run this, you can see that it actually does work. And so for homework, I just picked out a couple of questions to practice. I think strings and lists primarily. They may use conditionals like the if, else stuff that we learned as well. I know that definitely coding that is a little bit confusing to use at first. So I will post a couple more examples to Classroom so you understand how to answer these sort of problems. And hopefully after that, it should not be too difficult. I might be continuing using it, depending on how this week goes, at least. For your submission to Classroom, just screenshot like this page. Really, the only thing that's important is this part where it shows that you pass all the cases. You can include your code if you want, but just take a picture showing that you passed all the cases for that problem. Well, that's it. We're at 4 o'clock, so I'm gonna shut up now. If you have any questions, as always, I'll be sticking around. I'll be happy to answer it. If you're confused about how coding that works or whatever, happy to help with that. Otherwise, I'll give you your time back. Have a great weekend, and I'll see you next week.